the domain, that's going to be the furthest left x value, and the furthest left x value would be negative 4. All the way over to the furthest right x value, and that would be positive 7. And this is going to be an interval notation, so notice it's an open circle over here on the negative 4, so because it's an open circle, it gets a parenthesis. And it's a closed circle on the 7, so it's going to get a bracket. The range is the lowest y value. Notice x comes before y in the alphabet, and d, domain, comes before r in the alphabet. The x values match up with the domain, and the y values match up with the range. So the lowest y value on this graph is right here, and that y value is negative 2. So the lowest y value is negative 2, then the highest y value is up here. That's the highest y value, and that high y value is 3. So the range goes from negative 2 to 3, open circle at the negative 2 y value, so that's a parenthesis. Closed circle at the positive 3, and that's a bracket. Negative 2. When x equals negative 2, what's the y value? And that would be 1. When x equals 0, the y value would be 0. When x equals 2, the y value would be 2. The y value at that spot is 2. When x equals 4, again, the y value is 0. Whoops. How about when x equals 5? Now this is a little tricky. When x equals 5, I have a lot going on here. I have an open circle. There's no y value there. I have a closed circle. I have a y value there, which is 1. And I have an open circle. I don't have a y value there. So when x equals 5, y equals 1. The limit's going to be different, but the y value is the closed circle. When x equals 7, let's see what happens there. When x equals 7, way over here, when x equals 7, y equals 3. When x equals 6, coming backwards. When x equals 6, that's going to be 1, 2.5. This is slope now. That's the derivative. And the point we're trying to make here is that the derivative is the slope at negative 3. So at negative 3, it's not the y value. It's looking for the slope of this segment that point is located on. So the slope of that segment, which that point is located on, seems to be going downhill, so it's going to be negative. And then it's going to have a rise and a run. The rise goes down 1, 2, over 1, 2, 3, 4. Negative 2 over 4. So there's my negative, and that's actually going to equal negative 1 over 2. And notice at this spot, I go down 1, right 2. So the derivative, or the slope at that point, is negative 1/2. Huge concept in calculus. The slope at negative 2. So let's see what the slope is at negative 2. At negative 2, the slope of this segment is still the same. It goes down 1, right 2. So it's going to equal negative 1/2 is the slope at that point. Now it wants the slope at x equals 0. At x equals 0, this is rather strange. I have a segment, a straight linear equation, meeting a circle. And at that point where they meet, it's called a cusp. And you cannot find the derivative at that point. So that's going to be a big D, N, E. We're not allowed to take the derivative there. Now at 2, at x equals 2, again, a little difficult, a little weird. Notice it's a curved line, so I can't really take the slope of a curved line. So what we do is we take the slope of the line tangent at that point. The line tangent at that point is a horizontal line. And its equation is y equals 2. It's a horizontal line, so we're going to use this idea of Hoy, from Vux Hoy. And it's a y equals 2 horizontal line, and its slope just so happens to equal 0. So the slope at 2 is the very precipice of that circle, and it has a horizontal tangent line, and that's going to equal 0. And that's really important in calculus as well. What is the slope at 5? At x equals 5. Well, at x equals 5, notice I have an open circle at a point. That's a discontinuity. So you're not allowed to take a derivative at a discontinuity. So that's going to be DNE as well. That's also a DNE. No real verifiable answer for that one. And just do f of 0, but I can't always do that. So this is the limit of this function as x approaches 0. Now notice the 0 doesn't have any symbol up there. That means it approaches it from the left and from the right. And that spot where they crash into one another, even if it's closed or open, is going to be the limit. And that limit just so happens to be 0. Now the limit as x approaches negative 2. Negative 2, see it? Negative 2, but it's negative 2 with no symbol there, so it's going to be from the left and right. So there's negative 2, and I'm approaching it from the left and from the right. And right where they're about to crash into one another, the y value just so happens to equal 1. 4 from the right. Number 17 is a little trickier. So it says approaching negative 4, but it has a little positive symbol up there. That means I'm going to be approaching that spot at negative 4, that x value of negative 4, from the right. And I'm getting closer and closer. I don't know why I slow down, but I'm getting closer and closer to that point. What y value am I getting closer and closer to? It looks like it's going to be y value of 2. I don't actually have to reach it. I just have to get closer and closer. I'm reaching the limit. The limit is 2. Now, it says approaching 2, but it says from both sides. Notice, it doesn't have any symbol up there, so that's going to be approaching 2 from the right and left. So there's 2, and I'm approaching it from the left and from the right, and it's going to squeeze that spot right there, which is again at 2. Approaching 5 from the left. It's good I'm doing a left-sided limit to 5. And from the left, I'm coming along here. Notice, it's not going to be that top part or that point. It's getting closer and closer to this point, which is located at negative 2. Notice, from the left equals negative 2. I have to remember that. Then from the right, notice I'm approaching it from the right now. So it's 5 from the right. So let's see what happens when I approach 5 from the right. So I'm approaching 5 from the right this time, and notice this time, it doesn't equal negative 2, it equals positive 2. Oh, we have to remember that. Now the last one here says approaching 5, but nothing up at the top. So that means it's approaching it from the right and left. So notice from the left is negative 2, from the right was 2, because they don't equal one another. This is a jump discontinuity. So that means the limit does not exist, just like the mean girls. Right about here, I have to lift my pencil at x equals 5 to continue the drawing. So in this case, from negative 3, so from negative 3, starting there, all the way to 7 over here, there's going to be one jump discontinuity. 1. Let's see what happens now. How many places, how many times is this function not differentiable? So that means I have to count cusps. I have to count cusps and discontinuities and endpoints. So right now I have an endpoint, it's not differentiable there. I have a cusp, not differentiable there. I have a cusp here, it's hard to see, but that goes from a curve to a straight line. So yes, at x equals 4, there is a cusp. And here, this is considered one discontinuity at x equals 5. That's only one discontinuity. I know I have 2 holes and a dot, but that's only one discontinuity. And then I have an endpoint over here. Now is where I have to be careful. Notice it says on the interval from open circle -4. So there's -4, but it says just before it. So that means I'm not including this endpoint. That's not in my interval. I start the interval just to the right of -4, not at -4, just to the right. But it does go close bracket all the way over to 7. So I have to include 7. So this is a discontinuity. This is not differentiable. This is an endpoint, but I'm not including it in my interval. I'm only doing, there's 1 discontinuity or 1 cusp, so it's not differentiable there. 2, not differentiable there. 3, not differentiable here. And 4. So it's going to be 1, 2, 3, 4 times it is not differentiable. The area on that closed interval from -2 to 0. So from -2 to 0, notice we have a little triangle. And all I want to do is find the area of that triangle. If you need to know the area formula, it's 1/2 base times height. Or you can just look at this rectangle and notice that rectangle is 2 units, and the little triangle cuts that rectangle in half. So half of 2 units is going to give me 1 complete unit. So the area under the curve from -2 to 1, or -2 to 0, equals 1. So that little spot there has an area of 1. Now I want to find the area from 0 to 4. So that area is going to be the semicircle. So I need to find that area of that half circle underneath the curve. And the formula for area of a circle, if we recall, is pi r squared. And notice this radius is going to be exactly 2. So I'm going to place a 2 in for the r. 2 squared is going to give me 4. So this area is 4 pi, but 4 pi would be the area of the entire circle. I don't have an entire circle. I have half a circle. So what I need to do is cut that area in half. So that's going to give me an area of 2 pi. Now, from -2 to 4, that's from this spot over here to this spot over here. All I really need to do is add these 2 areas up, and that's going to give me 2 pi plus 1. Now 3, average rate of change, and all that is another form of derivative or another form of slope. Notice slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's the slope formula. For this, the formula is f of b minus f of a all over b minus a, where we are on a closed interval from a to b. And notice this would be my x values, and this would be my y value. So that would be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All I want you to do is fill this in, fill in the blank, not actually evaluate. I don't have a formula for you to evaluate it in. I just want you to plug in the 5 over on the left, the -2 over on the right, the 5 over on the left, and the -2 over on the right. Some people will go ahead and put +2. That's perfectly fine. Or if you want to do minus -2, that's fine as well. I'm going to set it up, f of 2. This is my a term, and this is my b term. Minus f of 0. Again, we don't know what f of 2 and f of 0 are. We are not using a formula. All over 2 minus 0. And there we go. I just want you to set it up. Go with the flow. F of, and this is my a, and this is my b. F of b would be f of 7 minus f of 4. So that would be my y sub 2 minus y sub 1 over my x sub 2 minus x sub 1, 7 minus 4. It's perfectly acceptable for you to put the 3 on the bottom, but you don't have to. All a function. And notice we have to plug values into that function. So I have my template over here to plug the values into, just to make it a little bit easier. And let's see what we're going to do. For g of 1, I take 1, and I'm going to plug it in for x. And notice I have x squared, so that would be 1 squared minus 6 times 1 plus 2. So that's going to be 1 minus 6 plus 2. That will give me 3 minus 6. That should equal -3. G of -1. So I want to put a -1 in for the x value. So I put a -1 in for the x value. That's going to give me 1 plus 6 plus 2. That should give me 9. I hope I'm not making any errors on the arithmetic. That's a big fault of mine. So I'm going to plug a 0 in to this x value. So I have 0 squared minus 6 times 0. That's just going to give me 2. Now I want to take the derivative of this. Using the general power rule, the derivative of x squared minus 6x plus 2 is going to give me 2x minus 6. And the derivative of 2 goes away to nothing. So that's where I have this template. 2 times something minus 6. 2 times x minus 6. And now I want to plug 1 into my derivative. So it's going to give me 2 minus 6. That's going to equal -4. That's the slope at x equals 1. This means slope. So I'm going to plug in -1 now. So let's see what happens when I plug in -1. So that's going to be -2 minus 6. So the slope here is going to equal -8. I want to plug in 0. The derivative at 0 is going to be -6. So the slope at 0 of this equation would be -6. Let's continue. Whoop, these are limits now. No longer doing slopes, now I'm doing limits. So the limit as x approaches 1 of g of x, this is going to be the same as doing g of 1. I plug that 1 in. It's not a graph. I can plug it in. It's continuous for all reals. So I'm just going to plug in 1. And I already calculated that over here, didn't I? So it's going to equal -3. Now I'm going to find g of -1. The limit of g of x as x approaches -1. I just plug it in. So I just plug -1 in there, and I already found g of -1. That's going to equal 9. I hope I did my arithmetic correctly. Otherwise, I'll be getting wrong answers twice. 1 plus 6 plus, yes, that's 9. So now I'm going to plug in 0. I plug in 0 up there and here. That's my limit. So it's going to equal 2. Moving on. G double prime. G double prime means take the derivative of the derivative. So the derivative of 2x minus 6 is just going to give me 2. Now this is kind of cute. There's no value to plug in a -1. So the second derivative at -1 is going to equal that 2. The second derivative at 0 is going to equal that 2. It doesn't change. With the formula x squared plus 6x plus 2. And it gives me the closed interval from 0 to 1. That means the 0 is my a, the 1 is my b. I'm going to plug in f of b minus f of a all over a minus b. Using the values, so that's going to give me f of 1 minus f of 0 all over 1 minus 0. So I'm going to plug in 1. That's going to give me 1 plus 6 plus 2. That's going to give me 9. Minus, I'm going to plug in 0 now. Plugging in the 0, f of 0 is 0 plus 2. So that's going to give me 9 minus 2 all over 1. That's 7 over 1. My final answer is going to be 7. Now I want to find the average rate of change on the closed interval of 1 to 3. So I'm just going to jump right to the fill-in. I'm not going to do the general formula. I'm just going to do f of 3 minus f of 1 over 3 minus 1. That's going to be 2. So let's see what 3 is. When I throw a 3 in, that's going to give me 9 plus 18. That's 27 plus 2. That's going to give me 29 minus, and then I throw in a 1. I think I already did that. I think I already calculated f of 1. That's going to be 9 all over 2. So 29 minus 9 is 20 over 2. My answer for number 45 is going to be 10. I'm sorry, I filled in the wrong answer there. The 7 goes to number 44, which is not in this screen. I'm going to do the average rate of change on the closed interval from negative 1 to 2. Let's see what happens. So that's going to be f of 2 minus f of negative 1 all over, be careful, 2 minus negative 1. So that's going to give me 3 underneath. That's going to give me 3 underneath. So f of 2, did I already do f of 2? I don't think so. Oh, I did. No, I didn't do f of 2. So let me do f of 2. I'll plug in a 2. That's 4 plus 12 plus 2. So 12, 14, that's going to give me 18. Minus, I did f of negative, no, I didn't do negative 1. I might have done it on another page. So I'm going to plug in negative 1 now. So let's see what happens. That's 1 minus 6 plus 2. That's going to give me negative 3. So I have to be careful. That's minus negative 3. People mess up on the arithmetic here. All over 3. So 18 plus 3 is 21 over 3. That's going to give me 7 again. My average rate of change is 7. An average rate of change is slope. Okay, when there are only 2, I'm going to set this 5x plus a equal to this 3x plus 2 when x equals 4. So that means all I have to do is take a 4 and plug it in for the x value. So when I plug a 4 into that, that's going to give me 20. Because 4 times 5 is 20. Now I'm stuck with this a equals, I take a 4 and I plug it into the x. 3 times 4 is 12 plus 2. This is going to give me 20 plus a equals 14. So I'm going to subtract 20 from both sides. A is going to equal negative 6. So find the value of a such that f of x is continuous. So when a equals negative 6, this function is continuous. I'm going to set these two equal to one another, and they meet at negative 3. So let's see, I'm going to have ax plus 2b is equal to 2x minus a at x equals negative 3. So I'm going to plug in a negative 3 for x, and that's going to give me negative 3x. I'm stuck with this 2b equals, when I plug negative 3 in there, that gives me negative 6 minus a. So, a palsy happened. I plug negative 3 in there, it's negative 3a. A lot of people, if you'll go back, you'll see the mistake I made. If I go back, you'll see my error, and here it comes. I plugged in the 3, negative 3 to x, and I wrote down 3x. That's something that we like to do for some reason. I have to fix that and put it negative 3a. Now I'm going to get the a's on one side, so I'm going to add a to both sides. And that's going to give me negative 2a plus 2b equals negative 6. Now, I have to set the bottom two equations equal to one another. But this time, at x equals 3, not negative 3, that's where the top two join. At positive 3 is where the bottom two join. So let me set that up. That's going to give me ax plus 2b is equal to b minus 5x. b minus 5x. And then I'm going to plug in a 3. This time I'm going to be careful and write 3a, not 3x. That's a huge mistake, a common mistake that a lot of people make. Equals to, I could have subtracted b from both sides instead of writing that out. If I subtract b from both sides, that's going to be 2b minus 1b is 1b equals. I'm going to plug the positive 3 into that. Negative 5 times positive 3 is negative 15. And notice I now have two equations with two variables, and I want to solve it for a and b. I'm actually going to take this over to a different screen so we can work on it a little bit more accurately. So I want to take this equation and solve the system. So I have negative 2a plus 2b equals negative 6. And I have 3a plus b equals negative 15. Now I divided each of these by negative 2 to make the equation easier. What I'm going to do this time is something a little different. I'm going to multiply the bottom one by negative 2, and that's what we're more comfortable with. Notice that's going to give me negative 6a minus 2b equals positive 30. And then I'm going to copy this down underneath of it. Negative 2a plus 2b. Notice the b's will simplify. They will eliminate. Negative 8a elimination equals 24. So a is going to equal negative 3. And then I take negative 3 and I plug it back in somewhere else. I'm going to plug it in here. So a equals negative 3. So 3 times negative 3, see the 3a, plus b equals negative 15. Negative 9 plus b equals negative 15. I add 9. B is equal to negative 6.